As we move into the section of statistics, it's very important just to make sure that you've got some good, solid foundations. So let's start by looking at some of the terminology, words that should be familiar, things you should know how to calculate. The first few on my list should be extremely familiar to you. Mean, median, mode, and range. Those are all terms that we've actually been looking at since the end of primary school. So those should be familiar. The second half of the list is a little bit newer. So let's first cover those first four just to check that our bases are in place. Okay, the mean, our symbol for that is X with a bar on it. Okay, so X bar is how we work out the mean. And basically what this is the average. Okay, and how do we work out the average of something? We add all of the scores together and then we divide by the number of scores represented. Okay, then we look at median. Median is the middlemost score. So in other words, right in the center of all your data, you find the median. Okay, and that we can actually work out what is known as the position of the median by saying if we have n scores, so n plus 1, then we divide that by 2. So let's say we had 20 people in our survey, then we'd say 21 divided by 2. That would give us the location of the median, and then we could go and check it in our data. Okay, mode doesn't come up too often at grade 12 level, but you never know. The mode is the one that occurs the most often. Okay, and if you move on to group data, you can have a modal class. So for example, most of the people I interviewed were between the age of 30 and 40. So then it would be the modal class. Okay, range is going to be just our maximum value minus the minimum value. But the range is not always a super accurate measure of spread because sometimes we have outliers. So just as a warning there, be wary of outliers because they are going to affect this data. Okay, so what we do is we then have other options that we look at. Just if there are outliers, then we might rather depend on the interquartile range, or we might even work out where the outliers are and then rather work without them. Okay. Now let's move on to the second part of this list. So we've got quartiles here. The median is in fact also quartile 2 because a second quarter is essentially a half. And so that's our median. But quartiles divide our data into 4 equal sections. So although we've got 3 quartiles, they do divide the data into 4 quarters. Okay, and how do we work out that? Well, again, we need to know the position of the quartiles. So the position of Q1, what we'll do is we'll take our data values, n plus 1, and then we can divide that by 4, or what some students do is they say, okay, I want a quarter of n plus 1, and this might help a little bit better as you move down in the calculations. Okay, why do I say that? Because then you could take quartile 2's position, and you could say, let's say that's going to be 2 quarters, or a half of n plus 1, and quartile 3's position will then be 3 quarters times n plus 1. Okay, so I have found most of my students prefer to write it like this, but you can write it as n plus 1 over 4, 2 times n plus 1 over 4, and 3 times n plus 1 over 4. Or you can just say 1 quarter, 2 quarters, and 3 quarters. And that will give me the position, and then I go and check in my data which score lies at that position, and then I can work it out. Okay, interquartile range, that's basically just the range between 2 quartiles. So instead of saying it's the maximum minus the minimum now, we are going to say the IQR can be worked out by taking the 3rd quartile minus the 1st quartile. Okay, and you even get such a thing as semi-interquartile range, which is sometimes asked, and that's when you take half of the interquartile range. Okay, semi, like semicircle, means half. So it's helpful if you know those prefixes, and then you can answer with understanding. Okay, an outlier is a value that doesn't relate to the rest of the data. So for example, let's say we wrote a test. Most of the students in the class are getting between 60 and 90%, but we've got one student who got 22. Okay, that student would definitely be an outlier, a data score that is just so far away from the rest of them. Mathematically, we can work out outliers. So we can take out, if we say quartile 1 minus 1.5 times the interquartile range, that would be anything smaller than that would be an outlier. Or, obviously, we can have outliers that are very big too. So that would be quartile 3 plus 1.5 times the interquartile range. Okay, so those are the ways that we would work out if something is an outlier. So if that comes up in your test, we can't just make a guess. We need to substantiate with calculations. And so this is what you would do. You would work out your interquartile range, times it by 1.5, and then you'd either subtract from Q1 or add to Q3. All right, and then brand new work that we learned in grade 11 with these two terms here, variance and standard deviation. Now, standard deviation is the one that we are commonly asked, and that is represented by a small letter sigma. It looks like a little O wearing a cap. Okay, and standard deviation is the amount that a data value deviates from the mean. In other words, how different is it? And that helps us to see how spread out our data is. Okay, and variance then is simply the square of this, and we actually need the variance to work out the standard deviation. So variance is sigma squared, and that is the variability of the data from the mean. In other words, is it very different? Is it quite similar? Obviously, if you have a small standard deviation and a small mean, that means your data is quite clustered together. Whereas if the values are larger, it means your data is more spread out. Now let's have a look at how this gets tested, because what used to be a great number of marks is now just changed to 2 marks for the mean and 2 marks for the standard deviation when we see it in our tests and exams. And the reason for this is because our calculators can actually do all of these statistical calculations for us. So it's not necessary for us to go to great lengths and show many steps. We just need to understand how to use our calculators. So let's look at this example. The test results of 15 learners are recorded below. So here we've got 15 raw scores, and we are asked to calculate the mean and the standard deviation, and then we are asked to interpret that standard deviation. So how many learners scored within one standard deviation of the mean? Okay, so let's get our calculators out. The first thing we need to do is get our calculator into stat mode. So you're going to push the mode button there, and then you're going to choose option 2, which is stat. You'll then get a whole load of other options. For this example, we're going to use option 1. For next week's video, we're going to move on to correlation and regression, and then we're going to use option 2. Okay, so it's about reading your question and choosing the correct mode. So mode, 2 for stat, and then 1 for variance. Now, what should pop up on your calculator is a table, and you can put your data scores into that table. And after each score, you are going to press equals. So we're going to type in there 9 equals 12 equals 13 equals. Grab your calculator, pause the video, type these values in, and then we'll calculate the mean and standard deviation together. First up, we want to calculate the mean, x bar. So once we've input all of our data, we've still got our table here on the screen. We're then going to press this AC button. Okay, don't clear your whole memory, don't switch the calculator off and on again, just this AC for now. And then we want to go back to our statistical options. So you'll see above the number 1, there's a little word there, stat. That's what we want to access. So we're going to say shift and stat. Okay, we want to get to mean and standard deviation. So we're going to choose option 4 for variance. And now we've got things that look familiar there. Number 1, n, how many data scores are there? Number 2, x bar, that's the mean, that's what we want. And number 3 there is going to be sigma x, which is the standard deviation. So we're going to start by choosing option 2, then press equals, and it gives us a mean of 23. Okay, then we're going to follow very much the same process. So again, the green button, or whatever color it is depending on your calculator, that AC button there, and we want to go all the way back. So shift to stat, we want to choose variance, and now we want to calculate the standard deviation because that was the next thing we were asked. So standard deviation, and that gives us 9,36. Okay, so there we've got the mean and the standard deviation, 2 marks and 2 marks. As long as you type carefully, you should be getting full marks for that. Then question 2 says how many learners scored within 1 standard deviation of the mean. What we need to realize, grade 12s, is that you could either be scoring higher than the mean, so plus 1 standard deviation, or smaller than the mean, so minus 1 standard deviation. So we're going to take our mean, we're going to say 23 minus the 9,36, and our second calculation, 23 plus 9,36. Let's quickly calculate those two answers. So what that tells me is that anyone who scored more than 13,64 and less than 32,36, they lie within 1 standard deviation of the mean. Okay, so let's figure that out. Greater than 13,64 is somewhere there, and smaller than 32,36, so smaller than 32 is there. How many learners lie between 1 standard deviation of the mean, which happens to be this number here? Let's work out 1, 2, 3, 4, 5, 6, 7, 8, 9 learners. So if they were to ask us how many learners scored within 2 standard deviations, then we would just subtract another 9,36 and add another 9,36. So we are basically just trying to figure out what is the deviation between the average and the marks that the learners in my class would have obtained. The box and whisker plot is a cool way of representing data that we were introduced to in one of the younger grades. And in order to draw it, we needed to put together what was known as the 5-number summary. So we needed to look at our raw data and we needed to say, okay, I need a minimum, which is this value here. Then I need the 3 quartiles. Quartile 1, the median is the same as quartile 2, and quartile 3, and those made up the box. So Q1, median, Q3, and then finally we need a maximum value, and that falls here at the end of the whisker. Okay, important to note about the box and whisker plot is regardless of how big or small these gaps may look, each of these sections of the box and whisker contains 25% of the data. Okay, and that makes sense because it's based so heavily on the quartiles. So if they ever say to you, what percentage of learners scored less than Q3, you'd go 25, 50, 75% of the learners. Then we are also asked to interpret the data that we get. Okay, and that can come to us here in a box and whisker plot, or we can get a histogram, and if we were to draw a frequency polygon, we could get some sort of a curve. And we would need to be able to understand, is this symmetric, or is this curve in some way skewed? Let's analyze these 3. If everything is evenly spread, and it makes what is a beautiful, beautiful bell curve here, then this data is said to be symmetric. If you have data that is perfectly symmetric, then your mean would be equal to your median. Then we have skewed data, like these next 2 options here, which is more realistic. It's very seldom that we find perfectly symmetric data. So skewed data can either be skewed to the left or skewed to the right. And what I do is I have a look at my curve and I say, where is the long tail, or where is the long whisker? Because that'll tell me to which side it is skewed. So in this instance, here's the long tail and long whisker. So this data here is skewed to the right, and this data here is skewed to the left. In data that is skewed to the right, the mean is going to be bigger than the median. And in data that is skewed to the left, the median is going to be bigger than the mean. One last concept that is super important to remember from grade 11 is cumulative frequency ogives, okay? Because that helps us to be a little bit more accurate when we are estimating things like the medians, the quartiles, etc. Even percentiles, we can become a lot more accurate if we draw an accurate ogive. So here's an example. The owner of an ice cream shop wants to know more about the ages of patrons in his store. He collects the following data. So he's checked how old are the people walking into his shop and how many of them. So 6 people were between the age of 0 and 10, 4 people between the age of 10 and 20, 3 between 20 and 30, etc. Okay. If someone was 10 years old, take a note that they would be here in the second class, because there it's not equal to 10, it's only equal to 10 over here. Okay, so the first thing we are asked to do is to draw an ogive, and then we're going to use that ogive to estimate the IQR. Okay, so what do I need to draw an ogive? Well, it's a cumulative frequency ogive, so I'm going to need to work that out. So the cumulative frequency, that's going to be a column that we're going to add here. And what we need to do is we need to then add, the frequency needs to accumulate. So in this first block, we've just got 6. In the next block, we've got the 6 from the previous row and the 4 that we've just gathered. So 10. Then we can add another 3. Then we're going to add another 7. And lastly, another 5. Okay, so that means 25 people entered the ice cream shop on the day that the owner did this data research. All right, and then some people, this last column is optional, but some people like to actually write down the points that they're going to plot. Okay, and I suppose it's helpful. What we need to do is we need to have, first of all, an anchor point. So don't forget that we need to anchor our ogive there at the very first class boundary. And then the points we plot are always the upper class boundary. So this one we're going to plot at 10, this one at 20, this one at 30, this one at 40, and this one at 50. And then the y coordinate each time is the cumulative frequency. So 6, 10, 13, 20, and 25. Okay, so you can, in each instance, just read it from here. So there's my anchor, there's x and y, x and y, x and y. Or you can do another column and have the x and y written down if you prefer it that way. Okay, let's draw this ogive, and then we are going to use it to estimate the interquartile range. So there's our ogive. Remember, it's a curve, not a broken line graph, so you want to try and keep it as curvy as possible. Okay, and now we want to interpret, so they want the interquartile range. So I need to work out quartile 3 minus quartile 1. So let's quickly work out the position then. Where are these quartiles located? So quartile 1 will be 1/4 times n plus 1. Okay, there are 25 scores here, so 26 times 1/4, we can just calculate that, 26 divided by 4. So at 6.5, that's the position of quartile 1, and the position of quartile 3 will be 3/4 times n plus 1, and that'll be at position 19.5. Okay, so now I'm going to pick up my ruler, and as accurately as possible, I'm going to figure out where these values lie. So what I did was I found 6.5 on the frequency, and I drew all the way up to the ogive and then down. That takes me to 11 years. I don't know if you can see that. Quartile 1 there would be 11 years. Okay, 1 block after 10. And then I'm going to do the same thing here. 19.5 to the ogive and then down, and that takes me to 39.5 years. So the interquartile range is 39.5 minus 11, and that gives us 28.5. A much more accurate estimate than we could ever get from grouped data like this. So this ogive is tremendously helpful.